Hello, beautiful people. This is part 1 for your Unit 6 pretest for Integrated Math 1. So this is exponential functions, geometric sequences, and things like that. So let's get started. Question number 1 is asking you to evaluate 6 times 3 to the x, where x is equal to negative 3. So we're going to rewrite this. 6 times 3 to the x. We know that x is negative 3, so we're going to substitute. So I have 6 times 3 to the negative third power. So we need to recall that when you have a negative, it flips the fraction. But then again, wait, 3 is not a fraction. But then it is. So remember that anytime you have a whole number, you have a 1 underneath it. So although 3 is not typically written as a fraction, it is a fraction with a 1 underneath it. So this negative tells you that, hey, you need to flip the fraction. And the negative, once you flip that fraction, the negative goes away. Everything else stays the same. So then that means I have 6 times 1/3 cubed. Well, this just means I have 6 times 1/3 3 times. That's what the exponent tells me. So 3 times 3 is 9. 9 times 3 is 27. Let's make 6 into a fraction. Actually, let me do this. So I'm going to finish here. So I have 6 times 1 over 27. That is the same thing as saying 6 over 27 because this is a fraction as well. And how do you multiply fractions? Across. So 6 times 1 is 6. 1 times 27 is 27. And then I'm wondering what goes into 6 that also goes into 27. I believe that's 3. 6 divided by 3 is 2. 27 divided by 3 is 9. So when x is equal to negative 3, our answer is 2 ninths. Okay, let's move on for this one. For the sequence 36, negative 6, 1, write an explicit rule. So explicit rule, we need to know that is a sub n is equal to a sub 1 times r to the n minus 1 power. Also, we need to know what our r is, our common ratio. Remember, we are multiplying by something. So I'm noticing from 6 to negative 6, I need to divide. So I need to divide by negative 6. Negative 6 divided by negative 6 is 1. So because we are dividing, we actually have to do the opposite because we need multiplication for our common ratio. So what you can do that is easier than kind of guessing is you're taking your right divided by your left. So your right term divided by your left term. So my right term is negative 6. Your left term is 36. And do that again. So your right term is 1. Left term is negative 6. And then simplify your fractions. So I have negative 6, 36. That is negative 1, 6. 1 divided by negative 6 is negative 1, 6. So because these match, this is our common ratio. So I'm going to start out my explicit rule by a sub n is equal to a sub 1 is your first term of the sequence, which is 36, or your term in the first position. So we have 36 times our common ratio, which is negative 1, 6. N minus 1. Keep your n. And that's it. And that's your explicit rule for the sequence given above. Write the next 3 terms in the sequence. Okay, follow the pattern. Just keep following the pattern. 27 and 9, 9 and 3. So this is, it looks like I'm dividing by 3, dividing by 3. So 3, let me do this again. So 9 divided by 27, 3 divided by 9. So 9 divided by 27 is 1/3. 3 divided by 9 is, again, 1/3. So multiplying by 1/3. So each jump is multiplying by 1/3, multiplying by 1/3, multiplying by 1/3. So then 3 times 1/3, 3 times 1/3. Well, that's 3 divided by 3. That's just 1. Then I have 1 times 1/3. That is just 1/3. third, and then 1/3 times 1/3, and that is 1/9. Okay, let's move on. Number 4. When a ball is dropped, the function given models the ball's height in feet after each bounce, where x is the bounce number. To the nearest hundredth, what is the height after the second bounce? And what is the second bounce? X is the bounce number, so we are trying to find x equals 2. So show your work. So we have f of x is equal to 10 times 1/2 to the second power. Again, what this means is 10 times 1/2 twice. So this is 10 times 1/4. This is, I'm going to make 10 into a fraction. So I have 10 divided by 4. So this simplifies to, I'm going to divide top and bottom by 2, 5 halves. And it's asking us to the nearest hundredth. So I'm assuming we're going to be using calculators. So let's type this. If it wasn't asking for in the hundredths place, then a fraction would be okay, but it is asking us. It is asking us to round. Okay, so let's do this. We have 10 divided by 4, or we can do 5 halves. So this is, it is asking to the nearest hundredth. So because there's nothing here, we have to put a 0. So this is 10's hundredths place. And then what is it asking? What is the height? And the height in feet. So you have to put units here. So it's 2.5 feet. The first term of the geometric sequence is 1. So a sub 1 is 1. The common ratio, r, is 3. What is the fifth term of the sequence? Show your work. So here you need to use a sub n is equal to a sub 1 times r to the n minus 1 power. We want to find the fifth term. So this is n equals 5. So a sub 5 is equal to a sub 1, which is 1, times r, which is 3. And then again, n gets placed on top of r. So we have 5 minus 1. So a sub 5 is equal to 1 times 3 to the 4th power. And then here's my thinking bubble. 3 to the 4th is 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So I have a to the 5th power is equal to 81. Now 81 times 1 is just 81. So a sub 5 is equal to 81. All right, let's move on to number 6. An experiment is done studying the growth in the population of rabbits on a rabbit farm. The function f of x is equal to this, represents the growth in the rabbit population, where x is the time measured in months. So far, there's no question. I'm assuming it's carried over to the next page. Turn the page. There it is. So how many rabbits were initially in the rabbit farm? I'm going to copy down the equation so that way I know what it is. So it's 110 times 1.25x. So 110 times 1.25x. Okay, that's our function. How many rabbits were initially in the rabbit farm? So before anything happened, what did we start with? Oh, this is 110, not 1. There's no point here. This is 110. So again, how many rabbits were initially in the rabbit farm? So if we take this away and we have 0 growth, oh, you can't see that. I'm sorry. Let me zoom in. There we go. Okay, so if we take the 1.25 away and we have 0 growth, sorry about that. I'm trying to get you to see. There it is. So if we have 0 growth, what would we initially start with? We would start with 110 rabbits. So what is the growth rate? Well, let's see if it says. We can get that from the equation, or we can see from here. Doesn't look like it says. It just says it represents the growth of the rabbit population. So the growth rate is the 1.25. Let me actually verify that. I just want to make sure. So the growth rate, I want to double check here. I'm gonna come back to it, but it looks like the growth rate, we would actually say growth rate would be just 25. So this 1.25 means that we take the previous, this is 100 plus 25. So we would take the previous amount and add 25% to that, but since it's just asking what the growth rate is, I would have to say it's 25%. And again, if that's wrong, I will come back and fix it. But right now, that's what I'm thinking. After 3 months, about how many rabbits are on the farm. So again, in the page number 1, it told us that x is the quantity of months. So since we have our formula, 110 times 1.25 to the x power. So then x is now 3. So 110 times 1.25 to the third power. This is where your calculator can help if you need it. 1.25 times 1.25 times 1.25, or 1.25 cubed. Okay, and then we're going to times that by 110. So about how many rabbits are on the farm? In my calculator, it says 214.8. So we're going to round up to 215, because you can't have 0.8 of a rabbit. So we're going to say 215 rabbits. All right, I'm going to wrap it up here for part 1. We're going to continue in part 2, and then in part 1, in part 2, I'm actually going to go ahead and verify that growth rate question. Okay, go ahead and continue watching part 2, please.